So we went over abstract classes and interfaces and what is an abstract class. It can have concrete methods, can have abstract methods, and can have instance fields or instance variables. The key word here is can. That means can possibly not have them as well, right? So interface is different because it can only have static final instance fields. You might want to look up what static refers to and what final refers to. And it can have abstract methods. Okay, so the keywords here are can. We can have an abstract class that looks just like a regular class, but has the keyword abstract, and it will be valid. It will compile. Right? Why? Because abstract methods is not a requirement; it's a possibility. And so abstract classes and regular classes overlap, right? If we have like a Venn diagram, I think Venn diagrams are the circles, right? The regular classes and abstract classes will have overlap, right? And then interfaces and abstract classes will also have overlap because let's assume we have an interface without a static final instance field and has 3 abstract methods, right? We can also have an abstract class with no concrete methods and 3 abstract methods and no instance fields. So they would look basically the same, they would perform the same, except this one up here would have the keyword abstract, the one below it would have the keyword interfaces. So when you look at this whole picture, you might be scratching your head like, why do we have these different types and why is there overlap, right? That doesn't make sense to me. So let's go over just, I guess, one example, and it might clear things up. But if you go on to Google and you type in difference between abstract classes and interfaces, you'll run into a lot of discussion that'll get you even more confused, right? I don't even like really understand the intricacies of the whole conversation, but abstract classes are generally used for one strategy, and interfaces are used to implement a different strategy. Okay, and if you do get into this discussion on the internet about these two topics, it usually comes down to the philosophy of the designers of Java, right? That they're trying to follow a certain philosophy and they're trying to be consistent. And so, yeah, we'll go over one concrete implementation of using abstract classes and interfaces. And so I guess the beginning of the conversation is why have parent classes and child classes, right? So if we look at this little picture here, let's say this models a car dealership, right? And we have GTR down here and Altima down here, and we have a car as the parent class, right? As a concrete parent class. So why have the concrete parent class? It's so that we can factor out any common instance variables from GTR and Altima, and we can also factor out any common methods, right? This saves us from rewriting these instance fields and the methods in each of the child classes, right? And we can assume that this is for the Nissan company, and so there are maybe 20 cars in their fleet that they offer. So, that saves us time, right? We want to be lazy programmers, so we create a parent class, and then everyone inherits from it. Okay, so that's the benefit of parent and child classes, right? It saves us time. So factor out any common variables and methods. Why have abstract classes? Okay, so let's assume we have this car family and we have this truck family, right? The car family has max passengers, has type like hybrid, gas, electric. It has calculate 0 to 60, right, based on different factors. And over here in truck, we have like payload, storage area, calculate MPG, like based on a argument, right? So like calculate MPG based on like a empty load and a full load. So that's the car family. Here's the truck family. And so we're going to create this abstract vehicles class, right? And so what is the point of creating this abstract vehicle class? It's to factor out any common instance fields, right? So any commonalities between on the instance variables between car and truck, we're factoring out and putting into the abstract class. Any common methods that we see in car and truck, the car and truck family, we can factor out and put up here, right? We can also add here abstract methods, right? And you would think, like, why would you need to add an abstract method? Well, what is an abstract method? It's a method that does not have a definition, right? Which means in any of the classes that are implementing the abstract method, you need to define those abstract methods, or that abstract class, you need to define those abstract methods, which means the implementation of these abstract methods are going to be different for the car, and they're going to be different for the truck. The code is going to be different, right? So yeah, so that's the purpose of the abstract method, right? Where you have two families that require different blocks of code in order to perform a certain job, like calculate delivery cost, right? Calculate delivery cost, I forgot what my rationale was, but over here we would have a different algorithm for calculating the delivery cost than for over here for the trucks. Yeah, I'm trying to think of something, but I don't think I can. Maybe we can. It could be based on like the number of cars that can fit onto the semi truck that hauls the cars, and then the number of trucks that fit onto the semi truck. So then you got to like divide that cost by by the number of trucks. And so anyways, the algorithm is going to be different, calculating the delivery cost over here, and it's going to be different from the trucks, right? So we have an abstract method for that. Okay. So what's the point is to factor out any common variables and methods, and define common methods that will have different definitions, right? And I wanted to also say implementations, but that might be a little bit confusing, because when you implement an abstract class or implement an interface, it's the same word, right? But when you're talking about methods and implementing methods, it means defining them, right? All right, so we have abstract methods. Now you're thinking, why have interfaces, right? What's the point of the interface? Well, here we could think of this as being one family, right, in the class hierarchy. And so what about if I like zoom out a little bit, maybe a little bit more, and we include a separate family, right? Let's assume that this is a model for a holding company, right, that has a set of car dealerships, right, over here on the left side, and also manufactures and sells like electronic devices, right? So maybe like a holding company that includes Samsung, right, and then also includes Nissan, right? I don't think that's the case, but if that was the case and they wanted to model all of their inventory that's out there, then they would have this family out here, right, with this class hierarchy, where they'd have a laptop, a desktop, computer being the parent class, washing machine, fridge, appliance being the super class, and then devices being the abstract class, where you can define, energy, parts, and the manufacturing costs, where each of these abstract methods will have different implementations here and here, right? Okay, so let's say we have these that are describing all of our inventory that's out there, right? And all the people who are at the point of sale, right, at the stores, are putting the information in as items are being sold, with regard to cost and sell price and all of these different things, and item number, right? But then up at the management hierarchy, you wanted to run a program where you can calculate the profit for all of your items that are out there, and maybe you wanted to add as an advertisement, blurb, the daily cost for purchasing the said vehicle or said device, right? Maybe that could be part of calculating the numbers on a lease agreement, right? So then we would create a inventory interface defining calculate profit, daily cost, right? And so these in the interface, the calculate profit and daily costs are not defined, right? They are not implemented. They don't have a block of code associated with them. But what this says, this interface, is a contract, right? What is the contract? If the vehicle class implements the inventory, the contract between these two is that the vehicle class or any of its subclasses need to define calculate profit and daily cost, right? If devices implements inventory, then that's a contract between devices and inventory saying that devices needs to implement calculate profit and daily cost, right? So if I am some kind of a senior software developer, and they're saying my manager is saying that they want to know this, they want to know the profit, they want to know the daily cost of all of the items in the inventory, what would I do? I'd create an interface, right? Define these two guys or declare them, put some notes in here saying exactly what I want for each of these, and then tell my managers to implement inventory. All right, so then the manager would go and they would go and change the code where vehicles would implement inventory, devices would implement inventory, and then their group of people that they manage would need to make sure that all the subclasses follow that contract, right? So by me, the supervisor, creating this interface inventory, I can be ensured that this software package will not run unless all of the child classes have implemented or defined calculate profit, calculate daily cost, right? So for me, it's beautiful. Like for like a management perspective, I just make a interface. I make sure everyone implements it, and then I wait for them to finish, and then I run calculate profit and daily cost, and I give those numbers to my superiors, right? So that's one implementation of this, and it gets a little bit more. There's more to it than this, but that's one example. And again, when you're dealing with this AP exam, you do not need to know the why. You just need to know how. Okay, how everything works and how to construct. All right, but if you wanted to kind of get a bigger picture idea of why, that's maybe one reason why.